So if we have a log equal to a log, then what's inside has to be the same number, right? The natural log of this has to equal, well, those numbers have to be the same. So we can write our equation, 5x plus 2 has to equal x plus 10. And then we can solve this. How do we solve an equation with variables on both sides? Subtract 1. So subtract the x. And so 4x plus 2 equals 10. And then we will subtract the 2. And 4x equals 8. And x equals 2. Now if I plug that back in, does it keep what's inside the log positive? That's what we're really checking for. 5 times 2 is 10, plus 2 is positive 12, and 2 plus 10 is positive 12. So we end up with the natural log of 12 equals the natural log of 12, right? Which is true. And what's inside the log is positive. If I plug that back in and what's inside the log is negative, then it's no solution, because that doesn't exist. So can you do number 2? Take a second and do number 2. All right, what do we get for our equation? Right, 10x minus 9 equals 2x minus 1. And we can subtract 2x. We get 8x minus 9 equals negative 1. Add 9. 8x equals 8, so x equals 1. Right? So that's our first method. That works when we have log equals log. Okay? The second method is rewriting logs as exponents. We're going to solve using that method. Remember that the log base 6 of 36 is equal to 2 because 6 squared equals 36. We can also write that as 36 equals 6 squared, right? And some of you noticed on the review sheet, on the answers, we were writing it the opposite way that you were writing it. You were writing 2 to the 5th first, or 6 squared first, and we were writing the 36 first. And the reason comes down to the inequalities here. When we're solving these inequalities that you'll see on example 3, we need to make sure we keep x on the same side that it started, and then we don't have to worry about flipping the inequality sign. If x changed sides of the inequality has to change with it. And so if we practice writing it with the x on the same side, then we don't really have to worry too much about losing the sign with an inequality. So for number 1, we have log base 2 of x minus 6 equals 5. So we're going to rewrite this as an exponent. What's our power? What's the base of our power? 2. So 2 to the 5th equals x minus 6. And I'm just going to put the x minus 6 on the other side to keep the x on the same side. So we're rewriting as a log, or as an exponent. And now, do I know what 2 to the 5th is? 32. And then I can add 6. And we get x equals 38. If I plug that in, is what's inside the log positive? Yes. So it's good. Okay. Can you try number 2? Rewrite it as an exponent. What do I get? 3x plus 4 equals what? 4 to the 3rd power, right? The base of the log is the base of the power, and that means 3x plus 4 equals 64. Right? And subtract the 4. 3x equals 64, and x is 20. Now notice on these that the x minus 6 and the 3x plus 4 is inside parentheses. That means it's inside the log. And so I have to do the rewriting before I can get x by itself. If you look at number 2, the minus 1 is not in, or I'm sorry, number 4 down here. This minus is not inside parentheses. That means it will need to be moved before. And the 2 is not inside the log, so we'll have to get rid of that first. Okay? So remember that parentheses means it's inside the log and you can immediately rewrite it. If it's not in parentheses, it has to be moved. So inequalities have the same problem as we had with inequalities in the square roots. We have a domain problem. If we have a less than inequality, it cannot go less than 0 because we can't plug in anything 0 or negative into the log. So we're going to have to put a second domain restriction on the less thans. So for this one, number 3, log of x is less than or equal to 2. What's the base if no base is written? 10. This is where it's really important we keep x on the same side. So x less than or equal to, what's the base? 10. What's the exponent? Squared. So x is less than or equal to 100. Now we're looking for our domain. X has to be greater than 0. If it was this problem here, x minus 6, then x would have to be greater than 6. If it's 3x plus 4, then x has to be greater than 3/4. Negative 4/3, sorry. So we have to solve. If there's parentheses, we have to solve. Set it greater than 0 and solve. If it's just x, then it's 0. And so we just add that onto the left side. It can be any number less than 100, but it has to stop at 0, because once it's 0, it's undefined. So number 4, we're going to need to isolate the ln of x. Okay, so if there's stuff outside the log, you have to get the log by itself. I'm going to add 1. 2 ln of x is greater than 5. Divide by 2. ln of x is greater than 5/2. What's the base of natural log? E. So how am I going to rewrite that? X is greater than, what's the base? E to the 5/2. We don't need to make it a decimal unless it asks for an approximate answer. That's the exact answer, e to the 5/2. Okay. Questions? Yes, Georgia. Because it's greater than, right? So the domain of a log is greater than 0, and because e to the 5/2 is greater than 0 and it's all numbers greater than that, then we don't have to worry about the domain restriction. Okay? It's really only when the x is less than we have to put that place that has to stop on there. Okay. Okay, and the last method, which it seems like a lot of the class like this method best, what's called exponentiating. It's a big word. It basically means we're going to make each side of the equation an exponent with the same base as the log. This method works whether you have a log on both sides or log equal to a number. So that's the nice thing about this. It always works as long as you only have one log on each side. So for number 1, what's the base of ln? E, right? So basically exponentiating means I'm going to take this and I'm going to make both sides e to the ln of 4x minus 7 equals e squared. Why? Because what happens with e to the ln? It cancels, right? And we end up with 4x minus 7 equals e squared. Now remember, if there weren't parentheses, I would need to add 7 first and then do the exponentiating. So now I can add 7. 4x equals e squared plus 7, and divide by 4. X equals e squared plus 7 over 4. And again, that's my exact answer. I don't need to go get a decimal. Questions on that one? So for number 2, log base 5 of 4x minus 3 less than or equal to 2, what base am I going to use? 5. The base of the log is going to be my big base. So the log 5 of 5 cancels. We get 4x minus 3 less than or equal to 25. It's literally the same thing we would have gotten if we had rewritten it as a log, right? 5 to the second power equals 4x minus 3. It's just a different way of doing it. The nice thing is that if we're not good at rewriting exponents, then we can do this method and it kind of does it for us. But we have to remember that 5 log 5 cancel. And now we're going to add 3. 4x is less than or equal to 28. And x is less than or equal to 7. Now what's my domain restriction? I have to find where 4x minus 3 is greater than 0. So we're going to add 3. 4x is greater than 3. So x has to be greater than 3/4. So we put 3/4 on this side of our equation.